A vehicle of mass 1,100 kilograms traveling at a speed of 37 meters per second when the driver notices a deer on the road directly ahead of her. She slams on the brakes and the vehicle skids to a stop with constant acceleration if the coefficient of friction between the tires and the road is mu k of 0.32. The deer doesn't move. What is the minimum distance, okay, between the vehicle and the deer when the brakes are applied in order to avoid a collision? Okay, so we're going to have a force of friction that's kind of cued to us mentally by this mu k. That's force of friction is always mass times acceleration, but in the case of friction, you're going to have the normal force times a coefficient of friction. Normal force in this case is going to be mass times gravity times mu k. So this is going to be our force of friction, and that's going to give us an acceleration. So we look at this part, we look at that part, we change over to another color, cancel the masses, so the masses cancel, and we're left with acceleration equals gravity times mu k. Okay, seems reasonable. Maybe it does. Okay, so now this is all going to be a kinematic equation, and we kind of are clued in by kinematics because we have a distance and we have an acceleration. So I'm going to write up the kinematic equations. So we have A is a constant, so acceleration, B equals AT plus V naught, and then X equals 1/2 AT squared plus V naught T plus X naught. And then you're like, I don't really know the T or time. Well, lucky. We can kind of combine these equations, specifically these two, to get another equation. Basically, we solve for T here, we plug that into this one, and then following some simplifications, we get kind of a pseudo fourth kinematic equation. I'm going to call this Vf squared, final velocity squared, equals initial velocity squared, times 2 times acceleration times delta x, which is a distance. Delta x is just the final distance minus the initial distance. So distance in this case. So then what we're going to do is, let's look at some of the values here. So we're going to assume that when the car stops, its final velocity will be 0. So Vf equals 0. The initial, well, that is, no, we're given that. It's like 37. 37 meters per second. 2, well, that's just going to be a 2. Acceleration, that is, we're going to be gravity times mu k. Times mu k, where mu is the coefficient of friction, and delta x is our question mark. That's what we don't know. So rearranging this, we're going to have, this part goes to 0, kapow. We have, I'm going to leave off the negative sign here, so VA, boom, 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 boom. Yep. Over 2a equals delta x. So what I'm going to do here is I'm basically, this g has a negative, it's negative 9.8 meters per second. I'm going to write it as positive 9.8 meters per second, and that kind of cancels out the double negatives. So that's why I haphazardly dropped the negative on there, because it looks cleaner, and this is just, if I got a negative distance, I just take the inverse. Reverse the polarity, so to speak. Algebraic inverse. Is this what we need? Is this what we need? What is the minimum distance? Okay, so I think we can solve this. Get the calculator. Pow. Calculator on, clear. V naught is 37, so we're going to square that. Then we're going to divide by quantity 2 times, and we know that A is, change this, G times mu K. Mu is 0.35, 0.32, 0.32. 0.32, okay? Back to the calculator. 2 times 9.81 times 0.32. Seems reasonable. And this should give us V squared. No, this gives us delta x. So this is our final answer, 218. Seems like a lot of meters. Maybe that's why there's so many collisions with deers. We have, 218 meters as a possible answer. So this is how we solve this problem. To kind of recap, our cues that we got here was we need to find a distance, And we're also given a mu k. So we use this mu k, like, okay, we're going to have to use force of friction here. Force of friction will then give us an acceleration. And that when we have an acceleration in distance, our thoughts should then go towards kinematic equations. We look at our kinematic equations, we're not given a time, and so we kind of solve for time and use the mystery fourth kinematic equation, which is worth memorizing. And we plug that in, solve for an answer, and we get our minimum distance. So I think that worked out pretty well. I hope that helped you guys. I will see you next time.